Okay, hi guys. So in this lecture we'll be discussing the stability of a carbonyl. So okay, let's get started. So we have a carbonyl. Let me first put on the heading. So okay, so let's suppose we have this reaction that we have CS3Cl, and what happens is CS3 actually take back the bond electrons from Cl, resulting in CS3 minus and Cl plus. Okay, so first of all, this is an example of A. This is a heterolytic fission. Okay, B. So the CS3 minus is a sp3 hybridized carbon due to the presence of a lone pair on CS3 on C atom. So sp3 hybridization on CS3 minus on carbon atom in CS3. Third point is carbon is getting electron rich. Fourth point is if we have attached to CS if the attached group to CS2 minus, let's suppose this is the attached group, let's suppose it's G. So if G has a minus I effect, then actually this implies stability of carbonyl increases, and if we have a plus I effect, the G has a plus I effect, then stability would decrease. The reason is but obvious, that we already have a negative charge on carbon atom in CS2 minus, and on the top of it we have a group which is having minus which is showing plus I effect. Then it will result in more unstability of the compound or on the carbonyl. Okay, so let's discuss free radical now. Then we'll be comparing the stability of negative charge on carbon atom in various compounds. Okay, so now discussing free radical. Okay, so let's suppose we have a reaction of this sort in which we have CS3Cl and both the atoms take their electrons back into their orbitals and thereby breaking their bond between them. So we would have CS3 with 1 electron on C atom and Cl with 1 electron on Cl. Okay, so this is an example of A, homolytic fission. B, we have as C is a all electron species, or the free radical on C makes itself a odd electron species, then actually this is a sp2 hybridized or a odd electron species. Okay, C is it's odd electron only, so I'm not rewriting it. So the free radical is electron deficient. Okay, so now if the D point again comes that on the top on the CH2 group, if you have a group G and if it is a minus I effect group, then actually it will result in decrease of stability would decrease of the free radical. But if it has a plus I effect, the stability would increase. And again the result, for understanding it is very simple, that if we have a electron deficient species and on the top of it we have a group which is giving or which has a plus I effect, then the slight shift of electron density would be towards the CS2 group or the CS2 dot group, hence the stability would increase. So free radical behaves the same way as a carbocation would behave. Okay, so now we have to compare the stability of the following intermediates. So now the question is comparing stability of following intermediates. Okay, so first we have something like this, wherein you need to compare the stability among these three carbon ions. Suppose they are formed as an intermediate in a reaction, you have to compare the stability of these three. So what should be the stability order? 3, 2, 1. Why? Because we have discussed, as the plus I effect on carbon ion increases, stability decreases. Okay, so order would be this. Let's see some more example. Here we have something like this, negative charge and NO2, and again we have, here is the negative charge and NO2 is here. Again, one would be more stable than 2, because here we have a minus I effect attached on negative charge, and here the distance of the minus charge gets one bond away, hence one would be more stable than 2. Nearer the negative charge, nearer the minus I effect on a negative charge carbon ion, more is the stability. Okay, we have something like this, CH2 minus, this is also CH2. We have Cl, CH2 and CH2 minus, and we have NO2, CH2 and CH2 minus. Okay, so obviously the stability of the third would be highest, because we have a here electron negative element having a positive charge here, hence the stability of third would be the highest. Now we have to compare the stability of 1 and 2. Okay, so what would be the order? Obviously 1 would be more stable than 2, because of the higher electronegativity of fluorine than chlorine, as fluorine is having higher electronegativity than chlorine, hence it would attract electron more towards it, hence the minus I of this compound is higher than minus I of this compound. Okay, I have shown 2 arrows here for just for the clarity purpose, hence 1 would be more stable than 2. Okay, let's look at the fourth example, wherein we have alkyl group, which is C only, alkyne group, and we have CH2 minus, and we have CH2 here, and we have CH2 double bond CH 2 and CH2 minus here. Okay, so what would be the stability order? 1 is more stable than 2, because the minus I of alkyne group is greater than the minus I of alkene group. Why? Because alkene is sp2 hybridized, whereas alkyne is sp3 hybridized, hence the sp hybridized, hence the inductive effect or the electronegativity of alkyne would be more than the electronegativity of alkene, hence minus I effect would be higher, as alkyne is more electronegative than alkene. Okay, let's look at the fifth example, where we have something like this, O negative, and so which is more stable, this one or this one? Obviously CD3 is actually will be having more inductive effect, plus I effect, than CH3, because it has one because it is having one neutron more than the hydrogen atom, hence it will be more plus I effect, it will be showing more plus I effect, hence the relative order would be, this strength would be the stability of this compound would be more than the stability of this. Okay, now let us see the next example, where we have second is this one, and third one is simply this. So it is more stable, 1 2 3. This would be the order. Why? Because more the inductive effect of neighboring groups on a free radical, more is the stability. Okay, stability order is similar to that one which we have discussed in the case of carbocation. Okay, so let's look at the last example on the comparison of stability of free radical. We have something like this, free radical here, free radical here, and finally on here. So which will be having more stability? Obviously the order still remains the same, 1 2 3. Why? Because this carbon is a 3 degree carbon, this carbon is a 2 degree carbon, and this carbon is a 1 degree carbon only. Hence this would be the stability order. So with this we come to an end of this lecture. We'll meet in the next video lecture. Till then, good luck and goodbye.